This map shows the distribution of the project that we used in the study. We selected 50 different projects, single-family new construction homes for the study, and we selected them from the projects that we work at EMU because of their distribution in the country, trying to get as much different climate zones and conditions as we could. These are actual projects. We're going to see that in just a sec. In terms of distribution by state, about a quarter of the projects are based in Colorado, another quarter or just about is in California, and the remainder is spread, like pretty much half the projects are spread across the country. In terms of climate zones, this is what the distribution looks like. We intentionally selected this project to be representative of different climate zones, so not too extreme for the hot, not too extreme for the cold. We have some of the extremes, but we wanted to balance out hot and cold climates to kind of have a more holistic response. You can see that the one regret I have I had in selecting the project is that hot and humid climate, we only had 2 projects. So climate zone 2A, we only had 2 projects. So it is represented, but it is somewhat underrepresented in this study. Overall, if you look at warm climate, mild climate, and cold climate, warm climates, climate zone 2 and 3, is about a quarter of all projects. That is intentional. Mild climate zones, climate zone 4 and 5, is about half the projects. And then cold climates, climate zone 6 and 7, is the remaining quarter of the project. That was intentional to kind of balance out the impact of different building standards in hot climates and in warm, cold climates. We're going to see how this impacts the result a little bit, and so we did this balancing act in setting up the study to kind of control this bias. Then looking at the elevation is something that we have a number of projects along the Rocky Mountains, and we didn't want that to skew the results too much. We have the average elevation of all projects. If you make an average elevation of all 50 projects, ends up being a little bit shy of 2,000 feet above sea level. This does have a little bit of an impact, especially when it comes to the draft of the 2024 IECC. We're going to see about that, especially when it comes to window selection. These are some screenshots of the projects from the Design PH modeling. Design PH is the SketchUp plugin developed by the International Passive House Institute, PHI, to combine the energy modeling with the design. We did this as part of the project boost that we do for projects, but these pictures is there to show these are actual projects. They have their architecture, they have the orientation, and mostly these are projects that came through our doors, not necessarily to be certified with Passive House. They came to us to improve their environmental quality, their indoor quality, their comfort. But they don't, in fact, 4 out of 5 projects that come to us, they don't pursue building certification, they pursue better building science than what building code provides. Compared to reference projects included in, for example, ASHRAE standards, these are actual projects, so they are less boxy, they are more real. Part of the intention of having 50 of them is also to blend out and kind of eliminate the impact of one building being very small, or one building having a ton of glass and another building is facing north. So one of the reasons why we had so many projects is also to kind of have a sense of what's going on with one building standard over another. In terms of, these are the metrics. You're going to see more tables like this in the next few videos. The 50 projects are listed from the smallest at the top to the largest at the bottom. Small and large in terms of treated floor area. You see the elevation, you see the number of bedrooms, you see the expected occupancy, as well as other criteria that are very important, such as the form factor. Not that we need to spend too much time on this table, but that is something that may come up later. In terms of size, the individual orange columns here each represent one building and each represent the treated floor area of that building. And the average size of the study, like the average square footage of across the 50 different projects, ended up being slightly over 2,500. I think it was about 2,600 square feet, representative of a typical single-family home new construction. When we factor in the form factor, that is what it looks like. This scatter shows the same average treated floor area of 2,600 square feet in the blue dashed line, and then the form factor is basically the square footage of the building envelope. So all of your exterior walls, your ceiling, your floor, divided by that treated floor area. And clearly, the smallest the number, the easiest it is to be efficient and cost effective. The higher the number, the more difficult it is. And this showed kind of the average building had a form factor about 3.4, which is kind of average for single family homes.